This episode of Hak5 is brought to you by Domain.com.
Hello, welcome to Hak5. My name is Darren Kitchen.
I'm Shannon Morse.
It's your weekly dose of Technolist. I'm very excited for this week's show.
I am too. Wait, why are we so excited?
Well, I'm actually not here right now. I'm at Tour Camp, so
That's
I
true.
hope you guys are joining me in Nia Bay, Washington, right past Forks with the Sparkly Vampires. And
Yay.
hackers and camping, it just goes so well together.
I'm excited that you're gone at the moment.
So you're just gonna,
just
so you're just gonna berate this avatar that is.
Exactly.
That works.
It's so much more fun in the office when Darren is not here.
I heard that you went digging. You went digging past the application layer, digging past the presentation layer, digging past the session layer. You went past the transport layer and the network layer. You went downtown to layer 2.
All these layers, I didn't even know all these layers existed. I just thought it was like code and GUI. Pretty much.
Turns out there's a lot of little interconnects in between that makes the whole thing work.
Surprise!
And so let's take a look at some of how these things work that we may take for granted. And this is the beauty of software-defined radio, is it not?
It is.
Typically, if, say, I wanted to, as a hacker would, want to debug or analyze some network traffic, say Ethernet traffic, right?
Yeah.
I would just start my Ethernet interface in promiscuous mode. I'd fire up my WireShark or whatever T-Shark, whatever TCP dump, however you want to sniff your packets, and then I'd just go to town, right?
Yeah, it makes it super easy. You have a nice graphical interface, so you don't have to worry about anything on the back end. It just works.
Yeah, it's like the barrier to entry in that regard is like so low that everyone can hack the Ethernet world because it's super simple. And actually, same way with Wi-Fi. I mean, you know, we've seen some fantastic dongles that we even have in the shop that are like less than $20 that allow you to, get your Wi-Fi hacking on, right?
Get some WireShark, is it?
Yeah, well,
Aircrack
Suite is a fantastic. I actually just had the great opportunity to meet one of the developers, Thomas, on that, and very cool, brilliant person. And again, it's all about bringing the barrier to entry down. And Wi-Fi got much stronger when the tools became available, and when the hackers actually had the opportunity to say take an inexpensive chip off the shelf and actually put it into a way where you can see what's going through the air, and then you're like, that's an interesting way that this handshake works. That's an interesting way that this authentication mechanism works. That's interesting the way that those management frames work and probe responses work and all those other fun things. And then we get pineapples.
Yay, pineapples!
So I hear, though, that the barrier to entry when it comes to that thing that we all take for granted, the shiny screen in our pocket that connects us with the world, is
you mean my cell phone.
your cell phone. The barrier to entry there is a little different because if I wanted to start hacking with the underlying technologies of, say, your smartphone on a GSM network, right, to like a T-Mobile or an AT&T or just about all of them throughout Europe, what would I do? I can't just buy a chip from Qualcomm. They're not going to sell it to me. No, you can't,
because they don't really sell to just self
They don't
businesses.
sell to consumers.
They don't sell to consumers.
Can't buy a onesie.
They don't even sell to small businesses.
Yeah, and actually, a lot of the big businesses that do buy these to create phones, which operate on huge, awesome networks, because there's not that much difference really between a cell phone network and a Wi-Fi network.
They don't even really know how it works.
They don't necessarily get all of the documentation. They get a chip. They're like, here's a chip, and here's an API to speak with it, and don't ask about the rest. Here's how to electrically
have some fun,
understand.
Don't have too much fun.
I hear, though, that you're having too much fun.
Oh, I wouldn't say too much fun.
Okay. Maybe a little legal disclaimer that we're not going to have too much fun on today's show.
No.
But we will take a look at some of the stuff going on in the air with GSM because Shannon, you got your probe going on in the air.
Oh God, that's so bad.
I know. I'm trying.
You and probes, I don't know, man. You're talking about this stuff all day.
Yeah. But no, AirProbe, another fantastic program that is going to allow you to get your little GSM sniffing on, huh?
Yeah, exactly. So I'm really looking forward to checking this out. But before we do, I guess we should explain what AirProbe is.
Or maybe what GSM is. Did you know that started before you were born?
GSM
in Paris?
Did?
Yep,
Wow.
1981. And GSM originally stood for Groupe Spécial Mobile or
Group
whatever.
speak. Management.
French-speaking person. It now stands for Global System for Mobile Communications, which is a backronym for something that means something a little bit more than a bunch of awesome hackers getting together in Paris and being like, hey, let's do radio stuff.
Interesting.
Yeah, all kind of comes back around, huh?
Around and around.
Well, I'm just saying, get some hackers together and technology happens. It's pretty cool. And it's the underlying technology behind your iPhone or my Android or whatever you're running, right?
Android, thank you very much.
Okay, but I'm just saying, it's like
I switched last
a link
year.
layer.
Yeah,
It's
I
like
learned.
down at the bottom.
That's true.
Yeah. So let's sniff some packets and find out how GSM works, huh?
Yeah, let's do it. So that's exactly what AirProbe is. It's open source GSM protocol decoder, which it uses software-defined radio. It will demodulate and decode GSM layer 1.
You're talking about the physical link layer,
Yeah,
right? We're talking about the actual attenuation of this antenna and actually being able to see the frequency modulated or, you know,
And it provides, and the second part it does is it actually provides layer 2 MAC blocks to analyze in WireShark.
So similar to what I would actually see if I went into monitor mode with my Wi-Fi thing, and I can actually take a look at the frames that are going through and then the packets that are within those frames.
Yes, exactly.
Sweet.
And then the nice thing about AirProbe is it comes with a whole suite of different products built into it. These include GSM SP, there's GSM, GSM T-Void, I haven't checked that one out, GSM Receiver, which is the best receiver in the suite.
Yes, those other ones
super,
were actually
super awesome.
other previous, I guess you would say, alpha incarnations of GSM receivers.
Yeah, and then there's GSM Decode and GSM Stack as well.
Well, it is a network stack, and so it is a suite that allows you to both receive that GSM traffic, but also to decode it into a way that's actually human readable.
Yay!
Yay!
I love these things. It's super, super fun. Now, of course, we aren't going to be decoding like encrypted phone calls or anything like that.
No.
That would be wrong.
Well, you know, there's ISM, there's the Wild West for the cowboys on the 2.4 gigahertz and the 900 megahertz and some other, you know, fun frequencies like that where it's unlicensed, but we're actually going to be looking at some stuff that would be considered licensed. And so with that, we should probably preface that maybe look but don't touch? I don't know. I don't know what I would love to start a discussion with you guys about what the legal aspect is on that. I know that it shouldn't be a problem whatsoever just taking a look at our phones,
Yeah, exactly, and that's what we're doing.
Right.
And we're using open source products that are available widely on the internet, and everybody uses them.
In fact, what's beautiful about this is by understanding the network architecture of GSM, one could thus create not just a GSM decoder, as the awesome people with AirProbe have, but actually create a base station similar to the base station for your Wi-Fi access point, which then cell phones could connect to. In fact, I know that this is possible because 2 years ago at Tor Camp, ShadyTel was there doing just this. And so I'm hoping that ShadyTel will be there again this year and that I can report back with even more good stuff as far as the legal manipulation of GSM for your own purposes, because, you know, networks are fun. Let's build more networks.
That is so, so cool. Now, should we get into like how many bytes are in this stuff?
Let's take a look at some of the packets and then we can actually understand what those bytes are and how they work.
Okay, so you want to take a break and then go back to it?
We're going to take a quick break, but when we get back, it's time to start sniffing GSM traffic. It matters not if you prefer a packet or a frame, or if a packet hits a pocket on a socket on a port. If you have the desire to enter the wonderful world of the internet, you need a domain name and web hosting, and you can get that very quickly over at domain.com, because these guys, they have a fantastic domain discovery system that will show you what your heart desires quickly and easily. Checkout process, it's a breeze, gonna have your website up and running in no time. And listen, the guys over at domain.com, huge fans of Hak5. They're so much fun to do business with because they're affordable, they're reliable, they're easy to use, and they're awesome on social media. You can tweet them at domain.com and see what I'm talking about. Those guys are crazy pants, and you can get some crazy pants savings just by using the coupon code HAK5 at checkout. That's right, go over to domain.com, check out with HAK5 and get 15% off. So when you think domain names, think domain.com.
I am so ready to have some fun with Kali Linux again, aren't you?
Kali is fantastic. We love the guys over there for taking all of the awesome tools and rolling it into one distro so that everything just kind of works.
So basically what we're doing today is we are taking the little RTL-SDR dongle, which is like, less than 20 bucks. It's available everywhere, as well as the hack shop. And we are using this to get GSM packets. We're going to analyze some GSM packets in WireShark using a couple of things called GNU Radio Companion, as well as AirProbe.
Right, and so if you've been following our software-defined radio series, we've been talking about a lot of these things in the past. We've used the Realtek dongle a lot. We've also been using GNU Radio Companion, fantastic open source suite to allow you to build software-defined radio programs. So let's get started.
All right, so first off, of course, I'm using Windows 8 computer. I'm going to use Windows 8 the entire time, except I'm also using VMware Player to boot into Kali Linux on this machine since it's fast.
You didn't want to do this in bare metal?
Yay,
I have a Kali box like right over there. Okay, we're
going
to do this in the VM.
But you know what? This is easier for editing.
Okay,
one computer.
Sure.
It's
all right,
good.
Go for it.
So I just plugged it in and I pulled up SDR Sharp like I usually do. Basically, the only thing I'm using SDR Sharp for in NFM, the radio version NFM, I've got it plugged into my RTL-SDR USB. I hit play. I'm going to be looking for GSM signals that are transferring in my area. So these may change depending on your location, but generally they're between 850 to 900 megahertz. The one I found specifically, and it looks like it's dropped a little bit, so I could always switch over to this one right next to it. This one's also a good one. I'm going to write this down because I'll need it at a later time. It's 869.224 megahertz. So if I pull up the volume, it sounds like crap.
Well, tune to something in the blue kind of next to it to give a comparison where, okay, so that sounds like static like I'm used to.
Sounds like static. That sounds like
digital static.
Some kind of digital
I don't know how to describe
this
it
otherwise. This one does too. It still has that digital noise to it. So what you're looking for is that kind of noise, that kind of waterfall where it's a straight waterfall path. You don't see any kind of breaks or anything like that. The stronger you get, the better signals you're going to be able to analyze whenever you get into Kali Linux.
Right, and we're not even getting into the whole GSM signaling thing, which in of itself is an amazing, awesome thing. Maybe we should touch on this again next week or something, because, or when I get back from TorCon, because it's really cool the way that it manages the channels, and there's so many of them, and we can then have a discussion about the different hardware and its better aspects of this.
Yes.
Because this is a $20 dongle that's not going to necessarily get us every packet, but
yes,
it's going to be cool nonetheless.
You will run into a few errors once you get this running, but hey, it works for the point of this. So first off, this whole segment, the tutorial, is also available over at RTL-SDR.com. They have a really nice write-up about it, but there are a couple of bits that I had to figure out myself when I was going through this, so I'm going to walk you through those as well. First off, you do need a couple of programs. You'll need Kali Linux, the VMware image, which Offensive Security has awesomely provided already, so you don't have to compile it yourself.
Or run it on bare metal.
Or run it on bare metal too, you can do that. So just download the image. It's very big. It's like 2.5 gigs, so it'll take forever to download. Don't worry though, it's there. And then you'll also need VMware Player. So you're going to end up running that Kali Linux image in VMware Player.
We should probably explain that we're using VMware in this case because normally I'm a fan of VirtualBox, right?
Yeah.
Because it's Oracle's VirtualBox, it's open source, it's fantastic. However, it's kind of not the best when it comes to USB throughput. When it virtualizes that USB interface, it kind of drops packets all over the floor, and that is not what we're going to want in this case. So again, another reason to run it on bare metal is that you wouldn't have to worry about using a proprietary hypervisor. But regardless, we're going to be using VMware because it works.
So just extract that 7-zip whenever you download Kali Linux, and then you just want to open up your new virtual machine in VMware Player. The password, again, this is Kali Linux, so it's username root, password Tor.
Interesting. Am I not at a conference called TorCon? Oh.
Lols.
Lols. Okay.
Oh,
Hacker joke to the one there.
So first off, a couple of things to mention. Kali Linux 1.0.6, 64-bit, that's the version that I'm using. 1.0.6 in particular, this one has GNU Radio Companion built into the program. So this is going to make the RTL-SDR dongle work in Kali Linux on VMware Player. Also, you want to make sure that your version of GNU Radio Companion is 3.6 point whatever. It's not the newest version, which is 3.7.
Which
that
is
version
included.
Is not compatible with AirProbe.
Which is actually included with the version of the latest version of Kali Linux. So if you just go to Kali and grab it, right now as we record this, it's what, 107?
I think so.
Say?
Yeah,
so
1.0.7.
So 1.0.6 has the older version. There's actually a patch to fix all of this.
Yes.
But it's kind of, I'm hoping that in 1.0.8 everything is all just fixed. But for the moment, we're
basically
just
everything should be compatible with AirProbe. And then the program that we're using, AirProbe, that's going to decode those GSM, the signals, the data that we're going to get.
Hooray.
So just to check that you do have the right GNU Radio Companion version, we're going to type in GNU Radio Companion tac version. I totally mentioned the same thing in my hack tip recently. So I have 3.6.5.1. So I'm good to go. That's going to be just fine with AirProbe. Yay! Now, if you do have the newest, of course, download the patch. It's over at RTL-SDR.com. Now, also, you want to make sure that you have the most updated version of apt-get. So I'm going to run that.
Well, you just want to update your repository so that you can get all the dependencies you're going to need.
Yay! So I'll update all that stuff, and then we can actually get into installing everything. So there are...
But before we install anything, it's always, let's get the dependencies.
Dependencies! Of course. So I'll wait for that to finish, and then my dependencies. So for this,
what are we going to need?
So
we're going to need to install a bunch
sudo
of stuff. What do we need here?
Yes, sudo apt-get, and then the first one is install git.
Of course.
You also need
git-core.
Git-core, and then autoconf. You also need automake. Oops, automake. And then we will need libtool, G++, Python dev.
TACDev, and swig.
Better spell that right, TACDev. Swig. I don't know what swig is, but it sounds really cool.
I want a swig.
libpcap 0.8.
TACDev, and before you hit enter on that, there's no space between git and TACcore.
Oh, thank you.
You're welcome. Also, you don't need sudo because you're already running as root, but whatever, it'll work anyway.
Too bad.
All right.
Okay, so once you get all that installed, you need more dependencies. So
well,
if you
looks like you've already gone through this.
I have. So if you have Kali Linux 1.0.5 or higher, you will need some more dependencies. Those include GNU Radio, GNU Radio-dev, cmake, git, libboost-all-dev, libusb-1.0-o, libusb 1.0-o-dev, libf for the win?
FFTW.
FFTW, swig, and Python numpy.
Okay. So with all the dependencies, let's get to just installing this guy. So let's clone the Git repo and start compiling.
All right. So git clone, and this is going to be git clone. What's it called?
It's over at osmocom.org, which, by the way, you should just go to osmocom.org because there's a lot of awesome information there about GSM and SDR and stuff.
Okay, so once you get that, you'll get that git. So yay! And then you can cd into that specific folder. So that's called libosmocore. So go in there, and then you want to auto reconf.
TAC-I.
Auto reconf. TAC-I, lowercase I. Let that run.
And then finally, we can configure, make, and install.
Configure, make, install. Yay! So
Repeat.
that's /configure. Then you want to hit make. Wait for that. Sudo make install. Yay! And then sudo ld config. I've already done it on mine, so I'm not going to run through all of that. Now, are you ready for the next part?
I am.
Woohoo! So now we're going to do AirProbe git compiling. Yay! So this is another git clone. So git clone.
You might want a CD.
Oh,
to go back a directory.
Yeah, you're right. There you go. All right, so git clone, and this is going to be git.gnu monks.org/airprobe.git. Hit enter and go ahead and let that clone over there. And once it's done, we want to install two the two most important parts of AirProbe.
Yes.
So these are
for our
going to be your
cases.
GSM decode and the GSM receiver. Those two are the important ones. So first off, to get GSM decode, you want to CD into AirProbe / GSM decode. Hit enter, and then we want to /bootstrap /configure and then make. Do you like my music?
Yes, I do.
Okay.
I kind of want a terminal now that does that whenever you run make. Although I kind of also want it to like be like tied in with make, and if it doesn't compile correctly, it goes dun 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 dun.
Okay. Now I'm going to
When you make your own distro, it needs to do that, by the way.
I'm going to go back to AirProbe and CD into GSM receiver, and once I get in here, I'm going to do the same thing, the /bootstrap. Hurry up! There it is. /configure. And then
make. Make
I
it
love all
so.
the pretty things. Look at it. Look at it go. And then make.
It's like better than scroll bars.
Make it so.
Mm-hmm. Command prompts. Watch them scroll.
Scroll
them all.
This makes for good
Race
TV.
them. Racing scroll bars.
So now that we have this, we want to CD again into a different folder. This is the src folder /Python. Hit enter. Now, we're going to test AirProbe to make sure that everything downloaded correctly and we have everything that we need. So to do this, there's an example C file available on the internets from the RTL-SDR.com blog.
So somebody has already captured that traffic with their software-defined radio, and now we can take those and send it into the receiver to see if it all decodes properly before we get to sniffing our own.
And I believe you called this a capture file.
Whatever have you. It's a .c file.
It's a
Works
nice
for
name
me.
for it. So to find this file, it's wget, and to get it, you're going to put https // and the website is svn.berlin.ccc.
Say.
berlin.ccc.de /projects
And props to say base.
AirProbe /raw attachment. These folks just need bake a freaking bitly or something. /d /wiki/d modulation /capture. So this is the actual file. Capture _941.8 capital M _ 112.c file. And then hit enter. You'll download that file to your Python folder. So I'm going to go ahead and hit Control-C because I already have this file on here. Now we want to get into the fun times. So we can open up WireShark with another terminal window. So I'm going to hit
Alt F2.
Cute little terminal up here.
No, just do Alt F2.
I don't want to.
But
I like my different
don't
windows.
have to waste a terminal.
Well, listen up. I like my different windows.
Okay.
WireShark. Bam.
Well, you could have at least put an ampersand at the end of it.
Be quiet. All right, so we have WireShark running. Now, it's already installed in Kali Linux, just in case you were wondering how in the world I got it. AirProbe dumps to UDP port, so you want to set WireShark to this thing called low. So this is loopback.
Right, so every Linux machine, you're probably used to WLAN 0 for your wireless or ETH 0 for your Ethernet. There's always low, which is your local.
Yay.
And so it's going to just spew those out as UDP packets on local, and then we can filter for them, and everything will be awesome.
Yay, fun times. And then you hit start. So I'll hit start. That'll bring me into the actual interface. And up here under filter, I want to type GSM tap to see anything that's coming through AirProbe. So specifically, this is going to give me all the GSM data. I won't see anything else. So
Great.
GSM tap, hit enter. So that is all set up and it's going. Now I can actually run that C file. So I'll go back over here and I'll type in, this is /go.sh, and that should already be there. Capture _941.8m 112.c file, and then hit enter. Bunch of packets.
Yeah, there we
and
go.
We're also
Racing
getting
packets.
Bunch of packets going on over here in WireShark.
Fantastic. Yeah, maximize
Yay.
that.
So we have things.
Things and stuff. So what are we looking at here? This is
GSM data.
Hey, paging requests.
Weird,
Type
huh?
1.
Isn't that cool?
This is so cool. Of course, everything is going to look for like the source and destination is localhost.
Right, of course.
But
But
system
this gives
information
us a really
type
good
2.
example. It lets me know that everything has already been downloading correctly, so I don't need to go back and re-download or recompile everything.
Oh, this one right here, system information type 4. This is a beacon, and we can actually
You found a beacon.
I found a
Awesome.
beacon. And just like with anything else in WireShark, we can actually come in here and see like where
my
where
gosh.
source and destination are going to. We can actually see
So
any of the
cool.
IP4 data, which it doesn't have. But this is the fun stuff down at the bottom.
Yeah.
Since we've got GSM tap, we can actually see the GSM header stuff. And we can even go into this frame a little bit more and see what other
goodness,
flags
it's so
are
cool.
set. So
This is so tiny. Put this in a big screen, everyone.
this is pretty cool.
Yeah, this is awesome. So we know that it's working, and this is good. And he's back here.
Sorry, I'm just like amazed. This is so much fun. Look,
I know.
mobile country code
You can totally
is set
do
to Germany,
Germany!
Federal Republic of. So the country code is 262.
Oh my God.
And then here's this 101 for T-Mobile Deutschland GmbH or GmbH or whatever.
That is so awesome. So of course we're not seeing calls and stuff like that. We are
Well,
seeing
no.
just
I mean, we should probably explain that don't expect to just run this through WireShark and then type it
Exactly.
into like a sound program and hear phone calls. It's not the way it works.
No.
It's kind of encrypted.
I told my husband that we were doing this, and he was just like, "Are you sure you can do that?" And I was like, "Yeah, it's fine. Whatever."
Yeah.
It's so cool.
So why don't we do it live? Because I'm in
All
airplane
right.
mode right now, and I want to see my association packets when I connect to the network.
So I'm going to get back into here. I'm going to minimize WireShark for now and minimize this screen. Okay, so I'm coming back over here. That C file has already gone through. Now we are ready for the live channel decoding, basically, in WireShark.
It isn't live in the sense that, it is live. It is, because you can actually
live.
capture it because we tried it 2 different ways. There's
We
a
did.
way where you can first capture it into a temporary file and then run that file through a GNU radio program that will then turn it into
Yes.
a file that you can read into WireShark. So that would be the store and analyze later.
Yeah, exactly.
You've actually got it set up so that you can see it real time?
I did. So this is kind of weird. Yesterday I tried to do the same exact thing, all the same same commands, and it didn't work when I tried to do the live decoding in WireShark.
So let's see if it works.
Okay, so let's see if it works this time. So the first thing you need to type in is this Python command, which is /GSM_receive_RTL.py.
Sweet, so they've already created a script specifically for this dongle. I love that.
Yes, they did, and it makes it so much easier
Remember
than
when we
having
were
to do it
talking about
yourself.
accessibility? I mean, when
Yes.
you've got a $20 SDR that makes all of this stuff, anybody can go and now play around with it.
Thank God. All right, so it's GSM receive RTL.py space TAC S space 1E6. Hit enter, and I got a failure.
Because
Oh, I know why I got a failure.
Why?
You know why? Because my RTL dongle is not connected to my freaking.
type LSUSB.
Yeah,
No, seriously, is it even connected?
it's not.
No. Okay. So in VMware, again, remember we were saying we were using VMware because
I know
its
why,
USB
yeah.
stack actually works. I think it's in the top right
It
somewhere.
is. It's
yes.
right here. So I right-click on it and click connect. So it's disconnected from the host. And then
If you run LSUSB again. Hey, look, I see a Realtek.
Where is it? There it is, right at the top, RTL. Okay, so I can
Okay.
run that command again and hit enter. Now a new window is going to pop up. Yay, we have a new window! But you see that it
Fantastic.
doesn't really show anything interesting quite yet.
Well, I mean, I see little fuzzy lines.
Yeah,
Those
fuzzy
are always
lines,
interesting.
yay. So the top window is the one that you want to pay attention to. This is the wideband spectrum. Currently, it's connected to this frequency 924.2 megahertz, but we want to change this. So this is where you're going to change it to the GSM one that you found earlier. So it was 869.2 M. Hit enter, and you should see it change.
Oh yeah, totally. In fact,
So-
hey, move that window. I'm seeing stuff in the background. Yeah,
Okay,
look
so
at that.
we're getting some errors here, and then some of them actually
But we're
hit.
also seeing decodings.
We are.
Ooh.
Yeah, pretty cool, right?
That is very cool.
So you do see a little bit of packet drop, but not too bad. And I do have my nice little dongle running here. Of course, if you get a bigger antenna, you're going to get a lot more information.
Bigger dongles are better.
Bigger dongles are better. That's
So
what she said.
that is in fact. So now how do we get this into WireShark? I want to analyze the data and see all the stuff happen.
Okay, hold
This
on,
is so
man.
exciting.
Hold on. This is cool.
All right.
So after a few minutes, you should actually start seeing GSM data in WireShark live. That's all you have to do on this end. So let's go into WireShark. And let's scroll down to the bottom. Okay, so we're still seeing the information from the file that we tried earlier. Once it does actually pick up this new request, this new information, it'll start pulling it up here. It may take a few minutes. For mine, it did take a few minutes once I actually tried it.
Maybe if we start and resniff. Continue without say. So we've got a new file, and we're just looking for GSM tap. Okay, so now we'll know when new packets come in.
Oh my gosh, my WireShark just blew up. See, it did take me a few minutes to actually get anything on this channel. I changed it over to 869.6M because that's the one that worked previously for me. So I just figured, let's try it again.
This is so cool.
So I'm getting a bunch of these ERR decode 12, decode 11.
Well,
9.
I mean, look
And
at the
then I end up
antenna you're
getting these other
using. I
ones.
mean, we're talking
I know.
about a $20 dongle with an antenna that's not even tuned to the proper frequency. So the fact that you're getting any frames at all is fantastic.
Yeah, I'm getting something. So let's see what we have. Paging request. Let's see, I can go in here.
Oh, and you've got system information type 1. So we're seeing beacons, and then we're seeing basically it talking to the tower.
That's pretty cool.
Like devices and stuff.
Yeah.
This is, I
pretty
have
awesome.
a feeling that this is quite the rabbit hole.
Oh, it totally is, dude. I could spend all day in here in WireShark. Oh my gosh, I could Google all of this stuff and be like, what does it mean?
Well,
But
you can actually find out that stuff because a lot of this is in the specifications are out there where you can actually learn, hey, what do these frames mean? And then once you are able to sniff the traffic and have a good understanding of the way that the whole system works, you can find the inherent weaknesses and actually make it the system better. Because trust me, this is not the same network like protocol running today that was dreamed up in '86.
Yeah.
This there's been several iterations of GSM, especially in regards to encryption and things of that nature. So we can talk about that at another time. But A5 for the win.
Okay, so we know it's working.
Yes.
Which is awesome. But what if I wanted to run the same thing, but I want to analyze it later? I don't have time to sit here and look through every single packet while it's doing it live.
Whoa. This is Python, right? Dude, I want these on every pineapple, and I want them in every street corner, recording to SD card, and then analyze. Oh, man.
We mentioned rabbit hole, right? So you can capture all this information to a file, too.
Cool.
So to do that, we want to go ahead and stop this capture. So I'm going to go ahead and close this out. And I'm going to cancel that. So it automatically cancels over in the terminal. And I'm going to go ahead and stop this capture as well. Oh, look at that.
Just do GSM tap filter again, because now you're seeing TCP.
Yeah.
You didn't want that.
GSM tap.
That was the purpose of having that filter.
Okay, so next thing we're going to do in a separate window. So I'll open up this window over here. So now I can capture into another window, capture into a file. So for this, I went to type in RTL-SDR / and I'm going to put it in my temp folder.
Okay.
And I'm going to call it RTL _
Oh, you've already created one, so
capture.bin.
call that capture2.bin since you've already done this.
Okay, we'll do capture2.bin. Okay, so this is going to create a new file, a .bin file /s 1.0 E6.
And then what frequency are you using?
And then frequency is
Are you going to use this 869? Well, which one was working best?
Yeah, I'm going to use the 869 one.
Okay.
That was working the best. 869.6.
E6 for megahertz.
E6. And then we want to put in the gain.
The gain, that's TAC G.
TAC G, and then 44.5. That's just the default, but you can set it to whatever gain you want to, whatever works best for your antenna. And then you hit enter. Oops. Wait, that worked last time. I didn't have to do /?
No. No, it's right there. Hang on. Type RTL- and then hit tab. S, type S. It's underscore. S. Yeah.
Oh.
So go up and change that to an underscore. Oops.
My bad.
It's all good. You know, Control A gets you back to the beginning.
There we go. Okay,
Sweet.
so right now what's happening in the background is I'm creating this bin folder based off of what the dongle is picking up from that specific frequency with that gain.
And you're just using the RTL-SDR program that's built into the RTL-SDR suite, which again, like I said, is on the Pineapple.
Super
How freaking
easy.
sweet is that?
Oh, that's so awesome. So let it run for a few seconds, and then whenever you decide that you want to get done, just hit Control C. Yay, and then it'll say it's exiting.
But now we've just got IQ data. We don't have like what we're going to need to throw it into WireShark. So how do we convert it?
You can't really do much with a bin. So now what I want to do, and I'm going to exit out of VMware Player real quick. I'm going to go back into here. Okay, so over at osmocomsdr.org, over on this website, there's a cfile.grc that you want to grab.
Okay, so GRC file is a GNU Radio Companion file, and like we've talked about before and we've shown how to do this, it's really cool because you can take these building blocks and kind of put them together, so you can have a source and an FFT and all of these different elements of a software-defined radio, and you can just link them together, and then it does all the heavy lifting Python stuff in the background.
Woohoo! So
this is already done for us, which we love.
Yeah, super love. So I'm going to scroll all the way down to the bottom of this website, and I'm going to copy the address to that original format. There we go. And I'm going to go back into VMware Player, and I'll go into my original window right here, and I'm going to copy that. I'm going to wget it. Control-Shift-V. There we go. Osmocom cfile.grc, that looks right to me, so hit enter, and that will download that file for you. So this is the GNU Radio Companion folder, or file, that's going to give you that nice little overlay, which, remember that episode? If you don't, go back and check it out, because we walked through GNU Radio Companion for you guys. Now we can open GNU Radio Companion from the terminal. To do that, GNU Radio-Companion, hit enter.
Again, with you and the ampersands.
Shut up. All right, so here we have it.
Oh, you have it open from last time.
I do. I have it opened up from last time. So this is RTL2832cfile.grc. The only things you want to change is the source file input and the source file output over at the other end. So source file input. So it's pretty small, but under here, file.
Yeah, hit the ... next to it. It'll make it a little
so you want to change that to the capture2.bin. So that's the new file that I created. Hit open. And you want to change repeat right here to no if it's set to yes, and then hit OK. And then the the output, you want to change the file so that it's in your Python folder that you have been chilling in all day in the terminal. And we're going to change this to capture.c file.
Or capture2.c file.
Yeah, we can do 2.c file. Capture2.c file, save.
Just keeping them together, you know?
Yeah. Hit OK, and
then let's run it.
So then you hit this, and it's going to execute that, and you can let it run for a few seconds. It finishes up really quick. Once it's done, you just hit the red X up at the top.
You do have to stop it manually, so just to make sure that this is still running and it's not like still writing to your file, you could ls that file continuously until it stops getting bigger, or however you like to do that. But yes, good stuff.
Yay.
Cool. So now that we've done that, we've converted it into a C file. How can we play this back into WireShark so we can analyze all the good stuff?
Yeah, there's a Python for that too.
Of course there is. Let's do it. Cool.
Okay. So I'm going to hit Control-C to go ahead and exit out of there because we don't need it anymore. This is /GSM receive. This is still in the Python folder that I've been chilling in all day. .py, and then we're going to use TAC capital I and put in the new file. So it's called capture2.c file, and then TAC D and 64. Hit enter.
Hey, look at all that good stuff. So if we go over to WireShark now.
Now in WireShark,
we'll see that we have new packets.
Maybe. Why aren't they coming through?
I don't know. Well, we're supposed to.
We're supposed to.
But that is the beautiful idea of this. And it does work. If you go back over to there, in fact, you'll see these are all 23-bit bytes of these frames. And you see where it says 2B? You see all of those 2Bs?
Yes.
Those are padding. So if the frame actually isn't 23 bits long, it's going to end up padding the rest of it with these 2Bs, or not 2Bs if there aren't.
I'm going to try running
less than
my other
23.
file. I'm going to try capture.c file, see if that one runs. Oh, it has gone over to WireShark. Why aren't you loving me? Love me, WireShark.
Oh, hit start.
Oh, that's
hit the shark, the green shark. Okay, now.
I'm slow.
It's cool.
Okay, 2.c file. Hit enter.
Yay!
There it is. Okay.
Packets, and they're going through pretty quickly too. Look at that. Fantastic.
Look
of
at
paging
all.
requests.
Yeah, lots and lots.
This is fantastic. Cool.
So cool. System information
This is
type
a lot
4.
to digest, but I think this. What's type 4 do? I don't know.
It says system information type 4.
Expand this good stuff down here.
Oh, LG bit globally unique address.
Oh, you know what we can actually tell is, this is the one that you just captured, the latest one?
Yeah.
We can see
resources.
we're looking at Singular Wireless, United States of America.
Oh,
so
Singular.
So you're on Singular Wireless's channel.
Whoa.
Yes.
Do you remember Singular?
Well, I think they got bought by
AT&T.
I don't. Oh, did they?
Yeah.
Well, there you
Who's on
go. So we're looking at AT&T's. Maybe they just left the packet. Maybe they just like didn't change the base station or what is broadcasting. There's a lot of fun
so cool.
GSM hacks too, because it's kind of ridiculous, the protocol.
That's
I
awesome.
implore you all to take a look at this.
That's so cool.
Hooray!
Singular.
I can already start imagining all sorts of fun stuff. But
goodness.
you know what? We want to hear what fun stuff is on your mind and what experience you guys have had with this as we just begin to get our feet wet with GSM. So where can they email us, Shannon?
Feedback at hak5.org, Darren.
That is, in fact, my favorite email address. And I believe we have a trivia question.
That's right, we do. We'll be right back with trivia. We're back, and it's now time for the trivia question of the week. Last week's trivia question was, Windows 95 originally was set to be released in what year? And the answer was 1993. This week's trivia question is, what was Windows 95 originally named before it was called Windows 95? You can answer that over at hak5.org/trivia for your chance to win some awesome schwaggity swag.
You're not talking about the Windy City, are you?
Shh.
Are you? For real?
Shh.
Oh, okay. I'm just not sure if you're talking about the code name or the...
Yeah, the code name.
Oh, well, in that case, oops. We thank you so much for continuing to put up with us, and we value, as we said, your feedback on not just the GSM segments, but anything in general you'd like to see us cover. Feedback at hak5.org is the place. We also have a place where you can find dongles. In fact, you can get your dongle bits over at, where is it?
hakshop.com.
Yeah, it's com.
Okay.
You just click on the store link on the Hak5 website. Or if you're watching on YouTube, Google it or something. I don't know. Thank you, though, because that keeps us going, and we are very excited to continue going.
At DEF CON.
Yes.
All night.
DEF CON is coming up,
drunk.
and we are going to be celebrating 9 years of Hak5.
We're going to party like it's 1995.
There you go.
With Windows 95.
I'll wear my flannel. Wait, oh, man. Anyway, with all of that said, though, follow us on the social stuff for the socially social at hak5.org/follow. Am I missing anything, Shannon?
I think you're good.
Okay.
And my name is Shannon Morse.
I'm Darren Kitchen, and until next time,
trust your Technolust. And your GSM packets.
oh.
Do they smell good?
Yeah! Go team! Over!
Ah! Woo! We did show! Ah!
No. So.